Sorry. Okay, now I hope you can
All
hear me.
good. I saw you highlighting stuff. I felt like you might have been explaining things.
Yeah, so I built this hash map where I was counting the number of times each character appeared in the target. So, I looped through with a for each of the character in the target. I converted it to a strings because you can't use primitive data types in as keys in a hash map because it has to be able to be a hashable. So you have to use strings. So I first checked, well, does it contain it? If it doesn't already contain it, I put it with a one value to begin with because we know we found the first occurrence. Otherwise, it means it did contain it. So I retrieved the previous count, I increment it by one, and put it back on the map. Now, kind of like you were doing this infinite thing where I actually did, where I first started my min make says -1, just as kind of a flag to check. So I loop through my keys, which are the characters that make up the target, and I do a check on the letters to use to see if that letter appears in that S string, and that's where I was telling you about your match function. But the Java version was like a filter, and I got a count of that. So the letters to use would say, and if I know that there isn't at least one appearance in this S, then I know I can immediately return 0 because we can't, we're missing a character. Otherwise, I do, okay, well, how many times can I make it? And that's a letters to use divided by whatever I had as my value for that particular key. If my min makes was equal to -1, and I know this is the very first time I'm in the loop,
Mm.
so I can set my min makes to can make. Else, I check if my min makes is greater than my can make, and now my new min makes is going to be equal to the can make. And then at the end of the loop, I return, or the end of the function, I return the min makes.
Gotcha. So you were dividing the letters to use by the comp count on every iteration of that loop. Okay.
Yeah, but because I was doing a loop through keys, I would only do it once for each character that made up the target,
Yes.
Right.
Yeah.
since keys have to be unique.
Okay. That makes
We
sense.
we were very similar to that.
Yeah. So what was
Yeah,
different?
actually, I like your Splice. I like your Splice solution more, and I'd have to figure it out the Java version. But let me go to. Let me see how I can go
Can
to.
you
I can
scroll
just go
down
to the
really
browser.
quickly though? I think the
Let me
big
go back. Sorry.
yeah, the big difference that you did that we didn't do though is if letters to use is less than one, return 0. I believe that's the piece we didn't have.
Yeah, and honestly, like I could just do a equals 0 and then return letters to use or return. There's different ways to do it, and it all
Yeah.
meant the same thing.
Yeah.
I was
Same.
just I was just doing kind of an old style of things I'd done in the past because I have a lot of things where like a 0 or a -1 can be returned in like this library I have to use for work because I have to deal with these um, vendor libraries. But let me change the title, go back to this one, and I'll go to like the optimum solution submissions. So like that solution, I think it was 7 milliseconds. Like I had one that was 6 and 8, but they were all similar. But then I found this version of someone put it where they used this frequency. Let me go back to the code. So yeah, this was what ended up being a lot quicker approach. So you take up slightly more space because you're making this interarray that's basically all the characters instead of doing a map. But like first they check an edge case where they go, if the target is greater than the letters you have, you can immediately return 0. So that's an
Right.
Yeah.
immediate exit out because you can't make it. But then they build this array that's the frequency of the letters, and since there's 26 letters, you can make this interarray of 26. So this is trading a little bit of space for more efficiency of time because it does a quicker lookup this way than
Right.
taking the overhead of a hash
And they
map.
said it's all lowercase, so that's
Yeah, and
the
it's all
key.
lowercase, so you can do a minus of the A character lowercase to get to that particular index. Then to get the frequency and the target, they loop through again, and they're just looping through each character, and they just increment the value that's on that particular index. So it's taking the same approach as a hash map, but things are quicker because hash map is an object that has some overhead built into it. So if you're trying
Right.
to come up with something that's the quickest possible and you're dealing with letters, often doing these arrays of 26 length end up
Yeah.
being a better
Fixed length
solution.
arrays are very efficient.
Yeah.
Yeah. Okay.
And then it's kind of like how y'all had that infinity. Java does have this idea of a max value on integer, so that was one way to take the approach to get something similar. Now, regardless, you're gonna need some for loops, and that's what's interesting about this approach is you're actually doing 3 loops, but because of the constant overhead of a hash map, this ends up being quicker. And
Right.
when you think about Big O, one thing they always teach you is you drop off any like multipliers or anything. So that's why you don't ever break it down to like 3n or 2n, and it's because the constant factor plays such a part that as long as you don't have nested loops, if you're looping through something 5 times, but they're very efficient, like if you have 5 different for loops of the length, but they're very efficient operations, that will often be better than sometimes doing a single loop but using a very inefficient operation, because
Yeah.
sometimes in the background of like an operation or library that you're using, it itself is doing a loop in the background. So without you even realizing it, you're actually turning your O of n into an O n squared.
Yeah.
Right.
Yeah.
Yeah, so you have to be careful about utility functions that actually do a loop in the background when you call them.
Yeah. Yeah.
But
I
here, I'm
like
going to
that
stop sharing
solution.
my screen.
That's good. That definitely didn't seem like an easy. I was surprised there
Especially
was.
those edge cases.
Yeah,
Yeah.
I was surprised that counted as an easy, because that took more like what I would expect out of a medium.
Yeah. Does anyone have the medium solutions?
I actually got a little bit stuck at the end, so I found a solution to the second one at the end that was very similar to the route I was taking. I had one little typo that I never really fixed, but it was not like this. Definitely was harder than the morning's questions.
Yeah, sometimes I feel like the difficulty of the entire competition is just abnormally difficult. You get those sometimes where even the easy one is just it's not easy. And then you go a few weeks where the easy one you bust out in 5 minutes kind of thing. Does anyone have even the first medium done? I didn't even have a chance to take a look at it.
Yeah, well, that's what I was talking about. Is I have a solution, but I didn't actually get it done before the contest ended. And the solution was something I grabbed from somebody afterwards, and I realized, oh yeah, I was close, but I had one little mistake.
Gotcha, gotcha. Um, do you want to share what you had? I didn't even have a chance to look at the problem. Let's see what
Well,
that is.
the problem is I overwrote it because it never finished it. It saved it since I was using the same language once. So I can go over the solution I ended up grabbing, but I just want to say, oh, it actually wasn't mine.
Yeah, yeah, all good.
All right, let me share my screen again then. Yeah, so I don't know if y'all even had a chance to really read the problem, but it was a bit tricky because what it was is you had a sentence, and in the sentence they would have prices, and then they would give you as an integer a discount to apply to those prices, and it was a percent. But what was tricky is they could mess with the prices by having a dollar sign appear after the number instead of before the number, and then that wouldn't count as a price. They could also potentially have a dollar sign in the middle of a number, and then that wouldn't be a price either. And so you wouldn't want to apply discounts to that.
Yeah,
But because it was dealing with words, the approach that I ended up finding, it would first split by the spaces to get the quote unquote words.
Right.
So you do that split. So now you have an array of strings, which and I've always seen the braces put up next to the data type. I don't know why they write it before the variable name. That was a little weird, I noticed. But anyway, so once you have that, you now have split it to where they're all the words separated by this space. And then they also have this new string builder just to kind of track what you're eventually going to output. So now you're looping through these words that you've split out using this split, and you need to check, okay, well, what's the first character? And a lot of things only apply if the first character is $1, because that means it could potentially be a price. So if it's not $1, you can just immediately add it, because it means that you're dealing with something that isn't a quote unquote price, because prices have to start with the dollar sign.
Yeah.
And then, and then you check and see, well, does the index you're at not equal to the length -1? And if it does not equal the length -1, then what that means is that you're not yet to the end of your sentence, so you're gonna have to put a space afterwards. But otherwise, you now know you're at the very end of the sentence, and if that's the case, then you don't need the space, because you don't want a space at the very end. But that's the simple case, if there isn't a dollar sign to start the word. But if there is a dollar sign to start the word, then now you have to see, okay, is this a price? So you're starting out then with the index of 1, and you're then having this other string P that you're going to use to track things. And the reason why you have to do an index of 1 is you don't really care about the dollar sign once you found it. You're actually caring about these digits that come after the dollar sign. So now you're going through and you're doing this while loop while your index is less than the temp.length, because if the index ever gets to the length, then you know you're out of characters. And you're doing while the character you're looking at for the index is greater than or equal to 0, so you know it's a digit, and less than or equal to 9, because you're only caring about digits, because they're talking about them all being integers, so you don't have to worry about dealing with decimal prices, thankfully, because that would have even complicated it further. So as you're going through it, you're basically just adding all these digits to this temp string that you're building. Then once you're done, you check if the length is equal to the length -1. And the reason why that would be the case is because you know your word is going to start with a dollar sign. And then you want to make sure that the length does not equal to 0, because if the length equals to 0, that meant you found no digits. So you know for sure it can't be a price. But if that's the case, then what you're going to do is you're going to parse that string you built and make it into a double. Then you also need to make your discount as a double. So taking that int discount that they gave you, which for example could be 50, the easiest way to make it into a double is you times it by 1.0 and then divide it by 100. So that gives you the actual decimal that you need to multiply it by to get the discount factor. Then what you do is you take the that double that you parsed out from the word, and you times it by this discount factor. But what that's giving you is the discount you're subtracting to the price. So your one last double is you now will take that value you came up from and actually subtract it from the price. Then when all this is done, you now have this temp string that you're going to have to format, because they tell you that they want there to be 2 decimal places, even if it is a whole value. So that's where this format string comes from, this parenthesis 1.2f. That's a way to tell it that you want it to be you want it to only show up to 2 decimal points, and that 1 dot means that you're always going to have at least 1 digit before the decimal. So that's why you have these zeros dot, 50, and it's 50 cents instead of just having it show .50. Now when you're done, you can add it to your output string. And then they just have this kind of a short circuit check that whenever they hit, whenever they add it, they now check, okay, well, is this the end of your array? If it's not, then you need to put a space. And they have but yeah, I mean, again, this is a medium, so it is something a little trickier. But once I found the solution, I kind of figured out what I was doing wrong. I was overcomplicating a little bit with my while loop, and I was trying to use 2 different indexes when I was going through it. But I was doing it a little bit odd. So I kind of see what approach they took, and it made a little more sense.
Gotcha.
But I'm sure, like, if you look now, I'm sure someone came up with a JavaScript solution. So
It's not extremely
you did not hear
difficult.
me say this, but I think regex would help.
Yeah, so let me see. Easy solution, split array, few lines. So this is what someone did in JavaScript. And this actually, to me, it looks simpler. Can you all still see this?
Yeah.
Yeah, and it's kind of, again, it uses a split, just like we saw in Java. We do a called Splice, but there's certain things that JavaScript can actually do a little bit easier just because it is untyped. So it's
Right.
easier to go
That
from
that
digits to
not a number
strings.
price is a good one
Yeah.
because that covers a lot of patterns.
But yeah, and I'm gonna, out of curiosity, I'm gonna paste this and just make sure. Every once in a while, you'll see somebody submit something that isn't an actual valid solution. But let me see what it runs. So the Java solution was 951 milliseconds and 121 megabytes. So it by far isn't that efficient. So let me try this. First, I'm gonna just run it with that. So okay, so it does look good there, and now I'm going to submit it and see what it comes out to. Yeah, so the JavaScript solution is a lot more efficient. It both takes less memory and it is a significantly quicker.
Is there a language that's inherently faster than others if you use it?
I mean, C and C++
Yeah, native
generally is,
code.
yeah, C and C++ is often known as being faster natively just because it doesn't have a garbage collector and stuff. And there's certain things because you're managing at the memory level that you often get quicker operations.
Yeah.
And you can do stuff with like bitwise, and like when you make an array, you're actually managing things with the pointers yourself. So when you're doing stuff in C at times, so there's certain things you can do that makes things quicker by actually getting to the absolute lowest level of memory management. But with Java, things are always going to be a little bit slower because you tend to more likely use libraries, and the garbage collector aspect and all of that makes it to where things are going to take a little more memory.
Yeah, that makes sense.
Yeah, like this solution in JavaScript, that to me is a whole lot more easy to look at than it would be trying to deal with the Java solution. Because yeah, look at this. This is 27 lines, but when you really think about it, only 16 is actual code. Like the rest was just the parameter, like the function header. Where Java, we started at line 1 and we ended at line 42.
True.
So it's 42 lines of code versus 16 lines of code.
Yeah, wow. Wow. Yeah, that's awesome. I like the JavaScript one.
Yeah, so but yeah, I just found it like people will put tags, so you can often do a search for a particular tag, and just so I found the JavaScript, and right now there's only that one person who posted it.
Yeah,
But yeah, I definitely call that.
it's not even a super difficult problem. It's just there's a lot of pieces to it.
Yeah, there's a lot of pieces you have to think about, but it's definitely
Yeah.
one of those problems where the more time you spend like planning out your approach, probably the better your end code is going to look. Like
Yeah.
I'm going to assume from this solution, the guy didn't just immediately start typing. He probably planned it out a little bit.
Yeah.
Right. You have to look at the permutations and which ones are valid and which ones aren't. It's pretty narrow. The ones that are valid is a whole
Yeah.
bunch of invalid ones and only a few valid ones. So
Yeah, but again, that is not a number. Was what made things a whole lot easier on the JavaScript side,
Yeah.
because that took a place of having issues where you had like a dollar sign in the middle of the number.
True. Yeah. True. True.
or the end. Yeah, it just
Yeah, yeah, or at the end, correct.
Yeah, that makes sense. Awesome. I don't even want to ask about the second medium one or the hard one because I don't think anyone even had a chance to look at any of those.
Yeah, I didn't have a chance to look at it, so
Yeah.
I could always grab some of the solution and try to explain it on the fly, but it's probably not going to be that valuable because I'm good at figuring things out quickly once I see it, but at the end of the day, I would just recommend if someone's really interested, just look at the discussion board, because especially if you come back tomorrow, like right now, people are still posting their solutions and all, but by tomorrow, I'm sure that the best solutions are going to get voted up.
Yeah.
And I'll go ahead and vote this guy up because that was a good